Hello, everybody. Welcome to our integration sync. Today, we're going to be getting updates on our domains, our execution layer, our internal messaging, and our external messaging protocols, cross-chain messaging. So to kick off, Li Cheng, do you want to update us on what you've been working on?
Yes, sure. So last week, not much new feature updates on the domains. The primary focus was on the XNet 2. For this week, the goal is to finish the initial version of the pilot domain registry and nail down the co-domain nodes implementation. Mostly, like the primary open question is how we integrate the co-domain node CLI into the subspace node binary. So by the end of this week, optimistically, the pilot domain registry is ready. By the end of next week, the co-domain node implementation can be ready. So in 2 weeks, hopefully, you can have the co-domain node. Yeah. And other than those, I have 2 documents about some questions on the domains and the co-domain nodes I have shared in the domains thread, and I also shared the co-domain nodes and CLI question in the engineering channel. Yeah. Yeah, that's my updates on my side.
Okay, thanks, Li Cheng. So I see there is one document for core domain CLI, but you said there's another document about domains that you shared in the chat as well.
Yeah, in the domains channel, I pinged you and Ved, and because it's something like related to the cross-domain messaging.
Okay. Okay, great. Yeah, and I think what we need to do is, since we're starting to get a lot of these documents and they're just kind of sitting in Slack, is in the Notion page, we need to just have a list of all sort of the open running question, issues, so that we can just have a single place to see all that.
Okay. Currently, those documents are put at the end of the design documents, yeah, as a notes section.
Oh, this is the Global Executor Peer-to-Peer Network doc? That's the...
Yes.
That's the one you're talking about?
Yes.
Okay.
Yes.
Okay, so you're blocked until those 2 get resolved, the open questions in each of them?
I just want to ensure we're on the same page. I'm not misunderstanding anything.
Okay. Okay, great. Do you think we can go through those really quickly and verify them? Or okay.
Yeah. Regarding the global executor between network, and so just a few things. So one thing is like the co-domain node has its own subnet, and we have global executor network, which is like formed by all the executors, which is basically the system domain network, right? So the messages between codomains are broadcasted or bridged via this global executor network, which is the system domain network, because all the executors runs the system domain node. So currently, like the messages between these codomains are basically wrapped in an unsigned extrinsic. So, and we rely on the transaction broadcasting over the network. So we need to intercept those like transactions. those transactions like specific to this like messaging, like for the cross like domain messaging. In order to do that, we basically have a way to intercept those exceptions on the transaction pool level, because when we receive transactions from the network, from the other peers, we have to verify this transaction before it can be really accepted by this node. So we can intercept on the transaction pool before verifying this transaction. And we already have this like similar like down the primary chain for the fraud proof verification. So it's not something new. We already have it on the primary chain. Now we need to like apply it the same way on the system domain or on the secondary node. So that's the idea. But there are some like, issues like before the code domains, the system domains nodes like cannot be connected to each other because we basically have two approaches to sync or to make the secondary chain move forward. One is to process the blocks from the like primary block. The other way is the traditional like block syncing. So you sync the nodes from other like secondary nodes, and we simply disabled the traditional block syncing because it's not necessary and can save some benefits. Furthermore, like supporting or like enabling both ways have some issues. So we simply disabled the traditional block syncing and have only one way to move the secondary chain forward, which is to process the primary block. So we need to, kind of fix that, and then we can have this transaction pool like wrapper on the secondary chain, and we can have support this cross-domain messaging.
Okay, so we don't have sync. So there's really not a notion of a secondary node. It's just a sidecar of a primary node.
Yes.
Really, secondary node can't work independently anymore.
Okay. Yes.
And this short-term solution is just to accept that?
I think the short-term solution is we need to like have to probably patch Substrate to solely disable the block syncing, and we can like have it for now to support this, like connecting to the other peers without having the block syncing issue, so that we can like broadcast the transactions over all the executors. I don't think that's a big deal because we already use a forked substrate, And once we have our own like networking layer, we'll have a nicer solution.
Okay. Actually, I don't. Yeah, I think we're going to have a side discussion on this. I think there's probably a different route that we're going to need to take, but let's take that offline. We need to have probably a one-on-one to go through some of the stuff in more detail.
Okay, can you guys also include me? I think this is most related to the discussion came out when we were talking about codomain messaging. I would like to get some.
Yeah.
Sure. Yeah.
Okay, let's pause on this for now. Let's move to the other issue about the domain node CLI.
Okay, so that's just it's more a technical problem, like how we integrate this like codomain of the CLI into the subspace node binary. The problem is that the secondary nodes or the system domain node, we specify the argument for running a system domain node by passing a raw argument from the command line, which collab supports only one raw argument. So we can't apply the same way to the other domain node implementation. So we need to find another way. And my current idea is that we add a new option before in body. Another way is more like an option of belonging to the primary nodes. Just you run the primary node from the command line. In that config file, we specify these arguments to run the codomain node. So I don't have any ideas if some other new better solution. I'm not sure. That's what I have right now. Yeah.
Okay, so the takeaway is that you really can't, you just run the core domain node, but you can't configure it from the CLI. You just configure it from the config file.
Yes.
Okay, I think that's probably okay for now. I just want to be careful about not making that a long-term solution.
Yes, it's not a long-term solution. And I do think in the long run, it's probably better to be done on the Subspace SDK or CLI wrapper side, which can have nicer encapsulation on those the running options.
Yeah. Well, we still want to be able to run a core domain. We've already gone back to the previous item. We can't run a system domain node in isolation because of the way, if we disable the block sync. But ideally, we should, using Substrate, we should be able, without a wrapper SDK, we should be able to run a system domain node in isolation or a core or any domain node in isolation, just using the standard tools and not have to use some third-party solution to do that.
Yes,
but I think for this iteration, it's
order
fine
to
to just
provide-
use this config approach.
Okay. Well, I'll
Sorry, go
just have to Nazar's opinion on this. Well, I always for
Yeah,
Nazar's
this
opinion.
is probably a good thing
For sure.
to discuss with Nazar. Yeah, he probably has some good ideas about how to handle this.
Yeah.
Okay.
Yeah.
Any thoughts from the group on this topic?
Blueshang and I, we spoke about it. Again, I think maybe further discussion that varies much more because there are a lot more things that we missed here in terms of routing as such. So and there are some missing blanks for me as well. But I'll talk more about it when I'm talking.
Okay. All right. Okay. Any other updates on your side, Li Cheng?
Nope.
All right. Okay. Sorry, Ved, you're up next.
Hey everyone. Okay. Let me- Last week, the main focus was between finishing up the fee model for the palette messenger and the relay work. The fee model is pretty much what we've defined as part of our messenger spec, and I've also updated some more details about how the fees are burned on the source side and how they are minted on the destination side. Per our discussion last week, they are already updated there. But the main idea for this was when a sender wants to send a message from a source domain to destination domain, we ideally collect fees when they send a message, and we distribute that fees to the relayers and also to the network at two specific points. One is on the source domain side, we distribute the relayers when the response has been received for a given message from the destination domain. So this is at this point ensure. So at that point, what happens is we distribute the rewards for every message that has been delivered, for which the response has been delivered. And the other point when we distribute the messages to the destination domain relayers is when the source domain sends the next message. Let me just quickly take it there. It's yes. Cool. Here, even when a source domain sends a message to the destination domain, it also sends along with the actual message. It sends what are the responses that it has received for the previous messages that it has sent, so that it's an indication for the destination domain to actually distribute the rewards. And that is what we do here. When the source domain, when the destination domain receives that n-1 number of message response has been acknowledged by the source domain, then we distribute that particular fee that we have collected as part of the inbox message that is coming in to the destination domain. We distribute it to the relayers at this point. This PR essentially handles the distribution logic and also the collection logic. It doesn't handle anything beyond the scope of the fee model that we have as part of the V1. Post this, the second one is the actual relayer. The first change to the relayer that went in was basically the core utility functions, such as submitting an outbox message or submitting an inbox message response to the destination domain. How we do that is essentially so this PR essentially handles the core utility functions. It doesn't actually handle the worker logic that listens to the system domain and then submits some messages, but rather we only this PR essentially handles just the submission part as such. The relay part and the listener part is coming next, and I'll take you through that later. What the main change that comes in was, give me 1 second. It's under the client relayer, domains client relayer. Yes, so this is, yeah, so the submit unsigned message here. So this is an entry point for a given block. So what we do is for a given relayer and a given block for a given domain, we get all the messages that are assigned to the relayer, and then we construct the witness for that particular, for each of those messages just for that particular domain, and then we submit them. And the submission is also very similar to how we do with the bundle submission as well. Let me take you through that. That is in the primitives. Yes. Yeah, so this is a little confusing. Okay, never mind. Yes, so that basically handles the initial core utils for the layer. There is a second PR that ideally makes a lot of sense when you take a look at the second one. Maybe that would help. This is a PR that actually monitors the system domain for every block that is being imported by the system domain. And then what it does is after k deep confirmation of that block, like, so imagine if we have, if a particular block X is imported, then we ideally want to relay X minus k deep block for that particular system domain. So what we do here is we take the messages that are present in that the newly confirmed block. When I say confirmed, it's just KD block from the best block, and then we take all the messages, and then we start to process them, submit the unsigned messages to the destination domain, and then we start to track once the messages are submitted here. And then we continue doing that for every new block that is imported. These changes are not yet done completely. The reason why we only do this domain is because we do not know how to route messages to the codomain yet. And ideally, we want to have that in before we could actually start routing messages to the codomain. So this PR essentially started out to handle that, and then there are some things that we need on the domain registry, such as the storage items to actually generate the state root storage proof. So those are still missing right now. I'm talking to Lushang post this call to figure out how to move while also not being blocked by those changes, so that we at least have a common defined API between me and Lushang, so that it's much more easier and not stepping on each other toes when I'm doing this. That's pretty much it for on the relay side. So at the moment, overall, we do have a way for a relayer to get started and relay messages from system domain to a codomain, but we do not have a bidirectional way back because we do not know how to route messages from codomain to another codomain or to the system domain itself. We could submit the messages, but some storage items are missing for us to actually validate the witness. And the next step would be codomain to codomains. That is still pending on how we route messages between using a single global network. So that follows once we know how to go about that. This one should be straightforward implementation because we do have all the proof verification and proof generation and verification for that as well. Yeah, that's pretty much it from my end.
Okay. Thank you for the update, Ved. I'll try to give some feedback on that global network stuff at the end here. But we need to have a design discussion with Miyu and Lu Chang soon about that. So we'll get something on the calendar like in the next 24 hours. Okay. Any questions for Ved or comments from the group? All right. Thanks, Ved. All right. Parth.
Yeah, so last week what I did was I updated Exchange cross-chain communication resources, added the one pager with a diagram that divides the popular chains into four quadrants. Sorry, popular bridges into four quadrants. Had a couple of onboarding call with Jeremiah, and we did go through the overall design of domains, messaging, and even I think we also briefly touched upon what we want to build in terms of cross-chain messaging. What I'll be doing this week, and technically I'm doing it from Monday itself, is I'm going through like the L2s. Specifically, I went through router protocol, hope protocol, eigenlayer as well. Eigenlayer was really interesting, just to mention that. And yeah, uh, have some more onboarding call with Jeremiah this week.
Great. Thank you, Parth. Would you mind kind of sharing your screen, pulling up that graphic, and just giving a high-level overview of the four quadrants and kind of how you're thinking about the compare and contrast of the different protocols that you've reviewed?
Yeah. Just hold on a second. Okay. You are able to see the screen, right?
Yep.
So it's in this exchange cross-chain basic classification. So okay, before I go to the one pager, the let me and so I divided the popular bridges into four quadrant. So the first and least secure quadrant is trusted plus no stake. So where there are bridges which are trusted by both chains. So specifically when I'm talking about the bridge, I'm talking about um, the the relay itself, which is transmitting message across. So in trusted and no stake, the relayer is not there is no stake held on by relayer on either of this chain, and the relayer is trusted, whether it can be a relayer or a set of relayer, as it in the case of multi-chain. um, the other quadrant is trusted, but there is a stake involved. So the relayer is trusted, but there is a stake involved in either of these chains. So for example, if we go by sorry, the relay is trusted, but relay has a set of consensus mechanism, and the stake is involved, where if some of the relay make mistake in submitting the data or anything, it will those relay can get slashed. Like this is true for XLR and chain flip. The next quadrant is trustless, but without stakes. So relayers are permissionless. Anybody can run relayer. Their only job is to have liveness, because both source and destination chain do not trust the relayer, either by optimistic verification sort of, or via mechanism of flight plan. Either way, they are not trusted. And the worst thing that they can do on their end is just not send the data. The most secure, in a sense, not necessarily, but by this classification, the most secure category would be that the relay are themselves trustless, but they have a stake on uh, they have stake on either their own chain or their the source and destination chain, either or. So okay, so let's go with trusted and no stake one. So in trusted and no stake, there are two entry. Binance CX is just a centralized exchange. There is neither stake involved in either of those chain, or it is trusted by both chain to act correctly. If it can act maliciously, it can just capture our funds and nothing you can do about it. Multi-chain is a special case. I have included here it in case of trusted and no stake, because um, it uses MPC to specifically like hold some accounts on source and destination chain and do some operation using SMPC service. But the nodes themselves are they do not have any stake either in the multi-chain network itself. Like they can leave and join at any time, and they do not have stake on both source and destination chain as well. So even though it's more secure comparatively than Binance CX, technically they multi-chain is trusted and there is no stake. In case of trusted and stake, both XLR and chain flip follows a design where both have their own specialized intermediate chain, in which they have stake, right? And every validator uses every validator. So for example, in case of XLR, um, it uses threshold signature scheme, and I think chain flip also uses something similar. So there are some differences, but overall the general idea is that it's a proof of stake chain with each validator holding some portion of private key, and only when majority of validator agree they can do something. And there is a staking, of course, in proof of stake, and the validator stake can slashed if it can be proven to the chain, intermediate chain, that they are doing something, like for example censoring or submitting or signing multiple things at the same time. So that is a trusted and stake. Yeah, in trustless and no stake, there are two example, IBC and Darwinia. In both cases, they are similar in a sense that the relay in itself is permissionless, but both chain holds a light client where when a relayer's responsibility is to if something happened on a source chain, relayer's responsibility is to have a cryptographic proof that can be submitted to the destination chain. And when destination chain has two things: first of all, if it recognizes that the block header for which sorry or the block height for which this state root is valid is trusted in the light client itself by the consensus mechanism verification. And the state root sorry the proof, the Merkle proof or any other kind of proof proves that a particular key value pair exists inside the state machine of source chain at a particular height, then the message itself will be accepted. um, so in this case, relayer hold no stake. Anybody can run a relayer. Their only job is to pass the message. The worst they can do is denial of service if they are colluding, but they cannot do they cannot maliciously like steal funds or anything. um, the next category, which is in which case the relayers are trustless and also they have stake. So if we go by here, there are different architecture here. So a hyperlane is the newest one. I read about it. So in hyperlane, there is a separate proof of stake instance for each chain validator, and it uses optimistic verification. So if your source chain and destination chain, both chain has their own instance of validator, plus a specific application on specific chain also have their own sovereign proof of stake validator. And it the validators are staked on, for example, for source and validator are staked to transfer the outbox message, and for the destination chain, destination validator are staked to get the outbox message from there. So well validators are validator stake, and they're trustless because hyperlane uses something called watchtower, where which are permissionless entities who are constantly monitoring that these validators are doing the right thing. If they are not doing, their stake will be slashed on the chain in which for which they are part of. Subspace, I guess you guys are already familiar with it, but and from the previous design that I read about it in the spec, each relayer stake on the origin chain in order to be able to relay message. And each chain, for example, be it a core domain or they have access to the primary chain as a source of truth. So they already have a valid state root for a particular domain, and it can be used to verify if a particular message is part of the counterparty blockchain state. So relayer has stake in terms of for transmitting the data, but and they are not trusted because you have to relayer has to submit the proof. It is not just given. In case of Nomad, it uses optimistic verification where relayers have the stake, right, and on chain from which they are submitting that message. And similar to Hyperlane, there are watchers that can submit the fraud proof, and chain can slash the node. Now the last entry is layer zero is kind of unique. So the if we strictly go by the technical design, layer 0 is not part of trustless and stake, because layer 0 do not require a relayer and oracle to stake. But I think here majority of people are going to end up using the reference implementation, in which the oracle is Chainlink, and Chainlink do stake on um, uh, basically their own on nodes. So by that logic, we have included layer 0 here. um, and if we go by that, there is a property of independence, that relayer and oracle, there is no trust as such on both of this. It's just that the weaker property is held up as long as that they both are independent. It is okay. So basically, if both are not colluding, then that means that it is the block header that will be received by the block header, and the transaction proof received by the destination chain will be valid. Or if both are malicious but they are not colluding, then they both are it is very hard to uh, like, the probability is very low to have a exact block hash on relayer and oracle's end. So if both are malicious but independent, then also the block hash won't match, and the message will be rejected. So yeah, this is the one pager.
Great, thank you, Parth. Wonderful overview for a very complicated topic. Any questions from the group or any comments on that? No? Okay. All right, thanks for the update, Parth. All right. Ning, anything on your side? Any updates to your onboarding?
Today I'm still going through the onboarding checklist. I start reading some material, and I may have some meeting, set up a few meeting. Yeah.
Okay, great. All right, I think that is it for today, unless there's anything else we need to cover before we close out. All right. Well, thank you everybody for watching. We'll be back next week with more updates, and enjoy the rest of your day.